Giracoin, the Swiss cryptocurrency. What is a blockchain and how does it work? Let's start with the key code SHA-256, called hash. A hash looks like a bunch of random numbers. It's a fingerprint of digital data, whatever is typed in this box here. When you type in some letters, you see that the hash changes for every single one. Now let's extend the idea of a hash and take a look at a block, which is very similar. The data section is now broken into three sections: the block, the nonce, and the data. The hash, which includes all the information, begins with 4 zeros, and because it does, since 4 zeros are unusual in a SHA-256 key, we can say this block is signed. What happens when the data of any field is changed is that the 4 zeros disappear, and the background turns red. So the block with this information in it is not a valid or signed block. And now the nonce comes in. The nonce is an additional number that has to fit with the hash, and the valid hash always starts with 4 zeros. You can see it's almost impossible to find a nonce number that generates a hash starting with 4 zeros. So here we have this button. It runs through every number, starting at 1, all the way up till it finds a hash that starts with 4 zeros. This process is called mining. Let's start the process. It stops at this nonce number, where we have 4 zeros in the hash. So here we have a signed and valid block. Let's go now to the blockchain and see how the blocks are put together. Here we have 5 blocks. There is a difference compared to the single block shown earlier, a field called preview. In the first block there are just a bunch of zeros, but let's see the preview of one of the following blocks. This number here is exactly the same as the hash of the block previously. And this preview number matches the hash of the other block before. Each block points backwards to the previous block. In the first block there is no preview, so we have just the zeros. What happens when some information is changed in a block? This block and all the following blocks are now invalid because of the preview to the hash of the block before. That's how a blockchain works to prevent a change. It would not be impossible to remine and remine every following block in the whole chain. And if this should happen, how would we know that the whole blockchain has been changed? Now let's go to the distributed blockchain. It looks exactly like the blockchain before, but here we have peer A. This is peer B, and it happens to have an exact copy of the blockchain. Here's peer C, and so on. There are many peers, in fact, copies of the blockchain. If someone would change a block and remine, and also remine all the following blocks until the end, and there can easily be 500,000 blocks in a chain, there will be differences in the hash code to all the other peers. All the peers are located on many different computers around the globe. That means that someone who wants to change a blockchain has to change all the blocks in the chain and, simultaneously, all the thousands and thousands of copies of the blockchain all over the world. And that is impossible. We hope you found this explanation of how a blockchain works to be helpful. Giracoin.